Hello, good morning, students. Welcome back to the new chapters. That is chapter number 13, sound. In this chapter, we shall be learning about the basics of the fascinating worlds of sounds. Okay, every day when we heard are produced by the living being, we also, as well as like non-living thing, we recognize the quick numbers of them without actually seeing their source. Okay, for example, like whenever the dog produces recognized by the sound of its bark, then or a crow produces a sound, your scooties or your vehicle produces a sound, but without any recognition we can easily recognize as non-living things or living things. They are producing by the sound, okay, through the sound and through the voice. Okay, so today we will be learning the most important topic, that is what we call sound, and sound is very much important for the next class, that is class 9. Okay, so in these very chapters you will learn only the basic and the terminologies that related to the sound. Okay, so here you see next you see what are the topics that we will be covering in these chapters. Okay, the first is we will be talking about introductions. Second, we are talking about the vibration that is cause of the sound and the tuning forks, and experiment to be proved that sound produced by the tuning fork is due to the vibration. Second topic. And next we will discuss about the some common term used for the sound, and do all the vibration produce sound. Then we also will learn whether all the vibration will produce a sound or not. Then we will learn about the sound need to be material. Sound really needs a material medium for the propagation, or ear, the natural gift for hearing. Why we have ears, what is the use of that ears, and how it grow. We will discuss about this. Why the sound difference between the like loudness and the pitch? How does that sound difference between the difference in loudness and pitch, and noise in the music? Okay, the sound produced by the human being. Okay, the musical instruments and the sound produced by them. So measures of the loudness of the sound and the noise pollution, harmful effect of the noise pollution, prevention and the control of the noise. So these are some topic that we are going to discover in this chapter, and this chapter is one of the lengthiest chapters. Okay, one of the lengthiest chapters, and I believe that you will be following all these video lectures. Okay, and which will be very much I would say which will be very much important for your higher classes. Okay, you see sound plays an important roles. Okay, sound plays an important roles in our life. Okay, they plays a very important roles in our life. It helps us to communicate with one another. Okay, if the sound does not produce, and how can I communicate with you, right? How can I explain all those things with you, right? So because of the sound, I can easily, the sound that produce, the voice that produce. Okay, the sound voice that produce, it helped me to communicate with you. It helped me to make you understand all those things. Okay, so um, we can recognize like we can recognize by the sound we can recognize the different living and non-living things without actually seeing them. Okay, as I told you before also, without seeing them we can easily recognize this the living and non-living things from the sound they produce. Like you talk about the dog, they bark, right? So we can easily, like your cat, right? And many more animals and non-living things are there where they produce a different sound. Okay, when you talk about like metals, they produce a different sound. When you talk about the plastic, they produce a different sound, right? So that's all about how it helps us to communicate, or it helps us to understand, or it helps us to recognize the things very easily but without seeing. So when you talk about the like if somebody is a blind, right? If somebody is blind, if the sound, if but his ear is good, okay, his ear is good, then he can easily recognize who is he can easily understand the things, or he can easily get in touch with the things with the sound. Okay, so let's try to understand what causes the sound. Okay, when the particles of the body move to and fro about in one position, it is said to be vibrate. And this to and fro motion is what we call a vibration. Okay, so most of the sounds are produced by the vibration. Most of the sounds are causes due to the vibrations only. The sound is produced by vibrating object. Okay, then we came to know that the sound is produced by the vibrating object. What is the vibrations? Okay, what is the vibrating? Whenever the object moves to and fro motion, to and four motions, right? So if the object is moving to and four motion, is what we call as a vibrating. Okay, if the object is moving from to and four motion, is what we call as a vibrating. Okay, to and four motion about emotion is what is said to be vibrating, and this to and four motion is what is said called to be the vibration. But when the object stop vibrating, it does not produce any sound. Okay, that means what we have learned from here is what, whenever the object vibrate, they produces a sound. Okay, so this is all about this in this topic. Now let's go with another topic, what is called tuning frogs. This is what we call a tuning frogs. Okay, a tuning frog is a U-shaped, okay, U-shaped frog with a steel medals. I'm sorry, the double A we have given. Okay, so try to scribble out with a steel handle. Here is the steel handle it is. Okay, this is a U-shaped. Okay, the two arms of the frog is what we call prong. Okay, this is what we call as a, this part is what we call as a, this two part. Okay, this two handle is what we call as a prong. Okay, this is what we call as a prong, and the one which is the handle, this is what a handle it is, and this is what we call as a stem. This is what we call as a stem, and it is convenient. It is convenient source of producing the sound vibration in it, and this two tongue is mostly used. Okay, this tuning frog is mostly used in the laboratory in order to let the student to learn how to practice, how to knows what to knows about the to knows more about the sound. Okay, so it is used mostly for the laboratories. Okay, let's try to learn about the what is it, let's try to learn about the experimentals. Okay, let's try to learn about the experimentals. You see, the experiment that we are going to prove that sound produced by the tuning frogs. Okay, you see, take a small thermocol balls and suspend it from an iron stand with a light steel tricks. Okay, so we are here, we are letting that thermocols and suspended, okay, from an iron stance. Okay, then it is, this thermocol is binded on here. Okay, so strike one end. When we strike one end of the pong, we try to strike one end of the pong outside. Okay, when we strike one end of the pong with one of the hard rubber bat, okay, then we can hear the sharp humming sound. Okay, they will produce some humming sound. Okay, now when once it strike, okay, we will now to touch this pong with this ball. Okay, when you touch this ball, they will start vibrating. Okay, they will start vibrating. Now let's say I will take this pong here. Let's say this is one pong here. Okay, so tuning frog, I mean, and I will hit it one of the materials here, and after that they will start producing some sound. Okay, they will start producing some sound like that. That sound is what we call humming sound. Okay, the sharp humming sound they will produce, and with the sharp humming sound, okay, when they are producing, okay, I will let it to bring nearby this this thermocol which is being bind here. So after some time you can see this ball, okay, is vibrating 2 and 4 motions. Okay, because of this frog, or this frog, yes. Okay, so we will observe that the thermocol blasts outward. Okay, these thermocols are flying outward. Okay, that's proof that the sound produced by the tuning frog is due to the vibrations of his pong. Okay, so whatever the sound produced by this tuning frog is due to the vibrations of this pongs only. Okay, so this is all about the experiments. Okay, I can re-highlight again once more. Okay, so I'm taking a prong here, the tuning frogs here, and I will let it to hit it some of the material, and then after that, after hitting, okay, I will in order to produce whether they are vibrating, because these vibrations, okay, the vibration that is produced by the tuning frog is like, is generally cannot be visible. Okay, but vibration to repeat to be seen by the human eye, so continuous repeat can be seen. Okay, so this vibration cannot be seen with our naked eyes. Okay, so what shall we do is that we will let it to bring and connect with this ball. Okay, so when it touches with the ball, then ball ultimately start vibrating. Okay, so when the ball vibrated, we can easily understand that whatever the sound produced by this tuning frog is due to the vibrations. Okay, because this vibration will affect another ball which is being in touch with another one. Okay, now you see, when you are standing in a line, okay, if somebody does not touch you, or if somebody does not vibrated among you, it is not going to affect you unless if you don't move. But if you move, that means someone is going to be impact, like someone is going to get in touch, and then they are also going to move out, right? So this is what we are learning, like whenever something vibrates and it affects others, and due to vibrations only the sound produce. Okay, so that is what about the vibrations. Okay, so let's try to understand about the, like, let's try to understand about the common term related to sound. Okay, the term related to sound, or the terminology related to sound, and this terminology is very much important for your higher classes. Okay, keep in touch with it. It's very much important for your higher classes. So what shall we do here is that vibration is 2 and 4 motions of an object. It is called oscillatory motions of an object. Now let us take a free suspended pendulum. This is what we call pendulums. Okay, so when it allowed to vibrate from end to end, if I allow to vibrate from end to end, okay, so when the pendulum is moved toward extreme C, okay, or right, or and stop for a moment and again swing toward in mean position, it will swing back toward here, okay, then toward the other extreme A, this one toward the right and left, okay, and then back to B. Okay, this to and fro motion is what we call as a vibrations. Okay, then the pendulums, which is to and fro, moving from here, reaching from here and reaches to here, again come back to this B positions again. Okay, again it reaches to again here. Okay, again it come back again to here. Okay, so when it reaches to back here again from the initial position and then gone back and then reaches back the initial position, that is what we call as a complete one oscillations. Okay, one oscillations. Okay, you see, first of all, we will try to understand the amplitude. The amplitude is what? The maximum displacement of the oscillating body from its central position is called as amplitude. What is amplitude? This is the amplitude. This is the total displacement, the distance between this, okay, this and total distance between this is what we call as a amplitude. Amplitude is what? It is the total displacement. It is the maximum displacement. Okay, it is the maximum displacement of the pendulum from its main position is called as a amplitudes. Okay, this is what we call as a amplitudes. Clear about what I'm saying? I think you are clear about what I'm saying, right? So when it moves from one end from B to A, from B to A, this is one amplitude. From B to C, the distance between A to B or B to C, the distance is what we call as a maximum distance, is what we call as a amplitudes. Okay, now what is the oscillation? The motion of the pendulum from one extreme position to another extreme position back to its main positions. Okay, the main position from what is it? As I told you, right? As I told you, it's okay. So here's I will just make it clear about this one. What is one oscillations? Okay, well, just try to clear it about one oscillation. Okay, let's try to be clear about one oscillations. So what is the one oscillation? You see, from this position, this is the initial position, means starting point. Okay, this is our starting point. I will write it here. This is a starting point. Okay, from this is a starting point. So from this here, it reaches to this one. Okay, first, and then it will return back to the B again. Okay, again from here, again it will reaches to A again. Okay, from here again it will reaches to back to 1, and this moving from back to this and this is what, from this point B to C, again C to again B, and B to again A to again B, is a one complete oscillation. Is what we call as a one oscillation. We have completed one oscillation. Okay, so this oscillation, this is what we call as an oscillation. Okay, so to and fro motions of an object is what we call as a to and fro motion of an object is what we call as a motion, oscillations. Okay, and that motion is what we call as a oscillatory motions. Okay, so now you see, what is the time period? What is the time period to make one oscillation to reach from one and back to B, from B to A, from A to again B. Okay, this is what we call one oscillation. And to complete one oscillation from reaches to here, come back to here, okay, and reaches back again here, this is one complete oscillation. And to complete one oscillation, how much time it is taken? Okay, that time taken is what we call as a time period. Okay, that time taken is what we call as a time period. Time required to produce one oscillation is called as a time period. Now let's talk about the frequencies. Okay, frequency. What is the frequencies? The numbers of oscillation in 1 second. How many oscillation does it take? Okay, now once again, how many oscillation does it take is what we call as a frequency. What is the question? Or you can also say the numbers of vibration produced by vibrating object in 1 second. Okay, you can also say numbers of vibration produced by a vibrating object in 1 second is what we also call as a frequency. Okay, in one frequency, the unit of frequency is always denoted by the hertz. Okay, and it is the unit of the frequency is given in order to honor the great like German physician that is called Heinrich Rudolf Hertz. Okay, in order to give a Heinrich Rudolf Hertz, who was a German physician. Okay, he produced the radio waves. Okay, when he was working about the radio waves, he produced a high, ultra high frequency with the help of repeatedly oscillating electric spark. Okay, he called this wave as the electromagnetic waves, and it is a wave which opened the way for the development of radio, television, radars, microwave telephony. And he also saw the light waves are also an electromagnetic waves. Okay, so SI unit of Hertz is the hertz is named after him. Okay, this frequency, the SI unit of frequency hertz, okay, is named after the a great scientist called Heinrich Rudolf Hertz. Okay, so when one vibrating body produces one vibration in 1 second, then the frequency is said to be the 1 hertz. Okay, in 1 second, okay, in 1 second, only in 1 second, okay, in 1 second, in time taken in 1 second, they produce only one vibration, one oscillation. They took only one oscillation is what we call as a 1 hertz. Okay, what we call as a 1 hertz. Okay, so time period, the time period always denoted by t. Okay, the time period is always denoted by t. Okay, so one thing here, it's important formula that we are going to learn. Okay, I will be writing here solely. Okay, I will be writing here solely, so please try to make it very clear about this one. I will be writing here. Wait for a while. Okay, so here is, you see, one frequency. Okay, one frequency, time period, the relation between the time period. Okay, relation between time period and frequency is this way. Okay, time frequency, time is inversely proportional to the frequency, inversely proportional to the frequency. What does it mean? If the time is increases, that means the frequency will reduce. If the frequency increases, that means if your frequency increases, that means time will reduce. Okay, so t, okay, t, I'm writing t this way, okay, is equal to what? 1 by f. Okay, if 1 seconds, okay, if your time is increasing, that means what is it, frequency will reduce. That means that frequencies, okay, the vibration, if frequency of frequency vibrations are completed in 1 second, if one vibration completed is in one vibration completed in 1 by f seconds, f frequency, the time taken to complete one vibration in this time period is what we call t is equal to 1 by f. And t mostly it is denoted, the time period is mostly denoted by the capital T, not the small letter t. I'm sorry, I have written small letter b t, but time period is always denoted by capital D. Remember this one. Okay, time period is always denoted by capital D. I believe you have understood all these video lectures. Okay, and in the next videos, please try to understand all these terms. If you're clear about the terms, okay, what we are going to learn in this entire topic, it will be very easy for you to understand. Okay, it will be very easy for you to understand. Please go to the video lectures and try to understand all those terms. Okay, so anyway, we'll try to meet you in the next video lectures. Anyway, stay safe. Bye bye.